let's discuss how to remove an element from a list. So first we have to find the node that we want to remove. So we're going to traverse the list. We're going to use some criteria to figure out what is it. Is it the first element? Is it the last element? Is it an element that matches a particular value? So that's going to vary depending on what we're trying to do. Let's say for this example we want to remove an item that matches a particular value. And let's say we match 10. So 10 is the number we want to remove. So that means we have to remove this node from the list. How do we do that? Well, instead of the previous node pointing to 10, the previous node should now point to 15. And that effectively removes it from the list. So we're going to traverse the list to find the node we're going to remove. That would be here. We also need to use a following pointer as we traverse the list so that we remember the previous node. Okay, because the previous node's next field is going to be set equal to this node's next field before we can remove it. All right, so here's the code. Let's look through it. Here's our example. Let's say I'm removing a node whose data matches a particular value. This is a list of integers. And let's say I'm looking for 10. So I initialize P and prev. P is my pointer I'm going to use to traverse the list. Prev is going to be my previous pointer, my following pointer. So I initialize P to be H. H is the first element in the list here. Okay. Prev is going to be initialized to null because there's nothing previous to the head of the list. Okay, so I'm going to walk through the list and find something that matches. As long as it doesn't match, I want to move P along. So find something that equals a val. But I put this P not equal null here to guard against falling off the edge of the list. What if I don't find the value that I'm trying to remove? What if I ask you to remove 50 and it's not there? Well, P is going to fall off the edge of the list. It's going to be null. And I don't want the while loop to continue in that case because I'm doing P data, I'm doing P next here, that would be a segfault. Okay, so here's my guard condition. As long as P is not equal null and P data is not equal to val, I'm going to move my 2 pointers. Prev equals P equals P next. Right? So move that along. Okay, once I exit this loop, there's 2 reasons I could have exited the loop. One is I found a match. And the other is, I didn't find a match, and P is equal to null. If I didn't find a match, then I don't need to do anything else. So the rest of my code is predicated on P not being null. It might seem odd to test here and here, but they're looking for 2 different things. So this stops the loop, stops looking when I fall off the edge. And if I fell off the edge, then there's nothing else to do. Okay, so if it's not equal to null, I do this. Okay, now I have this if condition because it could be that I match the very first thing to remove. And if that's the case, then prev would be null. P would be non-null because it would point to this node here, but prev would be null because we haven't moved along the list. So if that's true, if prev equal to null, we want H, which is the head of the list, to skip that node and point to the next guy. So it would be H equals P next. But if prev is not null, that means we moved at least 1 position along the list and prev points to a node. So we do prev next equals P next. So I copy this value, this pointer here, into that slot there, which means that this node then points to that node, which removes that node from the list. Okay? Depending on the code that you're writing, on the specification, you may or may not want to actually free this node. It's no longer part of the list. If you're the one managing the list, then it makes sense for you to deallocate that memory because it's no longer part of any list that anybody cares about. And so you would call free with an argument of P to delete this list. Notice that this is inside the if condition, P not equal to null. If P is null, there's nothing to free, so it doesn't happen. Okay, so be very careful about this. If there are other nodes, other pointers to that node that might still be around for some reason, we don't want to do that. But depending on your situation, this is typically what we would do here. The other thing that might change on your situation, of course, is this test here for not equal to. This works because integers, we're dealing with integers. If your data is a different type, then you might need some other mechanism to check for equality here. And it also might be some other criteria that you're using to figure out which node to delete. So this is a generic deletion function, but it's not the only way to delete something from a list. So finally, I'll notice that another way, a way to sort a list would be to find the maximum value of a list, remove it, and push it to the front of a sorted list. And you do that until the list is gone. So that's an alternate way to sort a list, but we're talking about deletion here.